So today we're going to be looking at section 4.3, which is all about congruent triangles. So far we've been talking about how to classify triangles by its sides and angles, and also what the sum of the interior angles of a triangle is, as well as how to find an exterior angle in a triangle. So what I want to move on to now is looking at congruent triangles. First of all, what does it mean to be congruent? What does it mean to be congruent polygons? And then getting into triangles specifically. So first of all, we need to define what exactly it means to be congruent. What it means to be congruent is two figures that have the same shape and same size. So not only are they shaped the same way, but they also have exactly the same size. So what does that mean for polygons specifically to be congruent? Well, that just means that all corresponding parts are congruent. All corresponding parts. So all parts that pair up have to be congruent. So let's look at those two triangles and understand exactly what this means. So here I have this statement that says that triangle ABC is congruent to triangle HJK. This is called a congruence statement. It's very, very important and really helpful when you're working on problems. So this is a congruence statement. It's very important to know. And what that tells us is that those two triangles are congruent. And so from the definition of congruent polygons, we know that all the corresponding parts are also congruent. So first of all, let's look at the sides. So we can look at sides and also angles. Those are the corresponding parts. So let's look at sides right now. So if you were to look at side AB in this top triangle, what side would it be congruent with in the bottom one? Well, that would be HJ. We can look at them and tell that they seem like the same. So we know that AB is congruent to HJ. And now, not only can we look at those and say, oh, those kind of look at the same, like the same length, but if you look at your congruent statement, they're both in the first position. We have AB is congruent to HJ. So that's how we know that those two sides are congruent. Likewise, we can look at the last two. BC has to be congruent to JK. And if you look at your triangle, it makes sense for BC to be congruent to JK. They look like they're the same. So BC is congruent to JK. All right, so we have one more pair of sides, and that would be AC is congruent to HK. So AC is congruent to HK. And again, you can use your congruent statement to tell you that. That's the first and last in each. So AC and HK. So now let's go to the angles, which are usually slightly easier to kind of pair up. So for our first set of angles, we have A is congruent to H. So angle A is congruent to angle H. And again, if there were more than one angle A, we'd have to use 3 letters. And they are also in the same position in the congruent statement. They're both the first letter. That's how we know they're congruent. Also, angle B is congruent to angle J. And then our last pair, so B is congruent to J, is angle C is congruent to angle K. And I can mark all those saying that they are congruent. So that's what it means for congruent polygons to have all corresponding parts are congruent. It means all the sides are going to pair up and be congruent with a side in another. All the angles in one are going to pair up with an angle in the other. So now let's look at this example. I just want to list out all the corresponding, all pairs of corresponding parts, just like we did in the last one. But now we don't have triangles, we have what looks like maybe a trapezoid, but we're probably just going to call it a quadrilateral by its 4 sides because we don't know for sure it is. So first of all, again, it's kind of easier to start with the angles, so let's start there. Let's list all pairs of corresponding angles. So A pairs with W. That is because they both have 1 mark. So angle A is congruent to angle W. And here we don't have a congruent statement to help us. All we can go by is the marks. Likewise, angle B is congruent to angle X because they both have 2 marks. Angle C is congruent to angle Y. They both have 3 marks. And angle D is congruent to angle Z because they both have 4. Alright, so that's all pairs of corresponding angles. Now let's look at the pairs of corresponding sides. So we know that side BC is congruent to side XY. They both have 1 mark. Side AB is congruent to side WX. Side AD is congruent to side WZ. And then finally the last pair, side CD, is congruent to side YZ. So the amount of pairs you have should correspond with the amount of sides your polygon has. So here our polygon's a quadrilateral. It has 4 sides. So we have 4 pairs of angles, 4 pairs of sides. All right. And what we could also do here is we could write a congruent statement. So if I wanted to write a congruent statement for those 2 figures, I could say that ABCD is congruent to WXYZ. Now I want to talk about that congruent statement a little bit more. When you are writing one from scratch, like we just did, they have to pair up to the angle they go with. So A and W have to be in the same spot. B and X have to be in the same spot. C and Y have to be in the same spot. And D and Z have to be in the same spot. Otherwise, the order isn't important. You just have to make sure that they pair up with what they're supposed to pair up with in the other one. So I could easily here write my statement as BCDA is congruent to XYZW. Alright, as long as, again, B pairs up with X, C with Y, D with Z, and A with W. They just have to pair up with the correct angle. So now let's look at this example. It says, in the diagram, we know that these 2 triangles are congruent to one another. Find the values of X and Y from knowing that. So since these 2 triangles are congruent, we know that corresponding parts are congruent. So if we can find corresponding parts, then we can solve for X and Y. So let's start with X. X stands for this angle right here. All right, that would be angle T. So if you look at your congruent statement, angle T pairs up with angle R. They are both in the first position. So I know that the measure of angle T is equal to the measure of angle R. So now if we can find out the measure of angle R, then I know what the measure of angle T is. So looking at R, we don't know it, but we do know that S is 90 and that this angle is 78. So I can find angle R. So if I wanted to find the measure of angle R, that would be equal to, remember all angles add up to 180, minus the other two, so 78 plus 90. Or if you notice that this is a right triangle, you could have also done 90 minus 78. And so if you work that out, you get that the measure of angle R is 12. So therefore, if the measure of angle R is 12, we know that x equals 12, because those were congruent. So that's how we can use corresponding parts to find missing measures. So now let's shift to y. So the place where we have y is this side RS right here. We have that 2y minus 1 equals length RS. So if we look at our congruent statement, RS pairs up with TV. You have to look at that congruent statement if you can't tell, because there's some sides that look almost equal here, so you've got to be really careful. So RS pairs up with TV, and we know that TV is 24. So I know RS equals TV, so 2y minus 1 equals 24. So that means that 2y equals 25. So y here is a decimal, that's okay. It's 12.5. So that's just using corresponding parts to find missing variables. Alright, the last thing we're going to look at today is called the third angles theorem. What the third angles theorem says is that if two angles of one triangle are congruent to two angles of a second triangle, then the third angles in those triangles have to be congruent too. That they also have to be the same. Alright, which should make sense to you. So what I want to do, I'm going to draw two random triangles over here on the side. And we're going to see if the third angles theorem checks out. And I'm going to make them look as close as I can to the same size, but I'm going to be a little off, and that's okay. So let's say that this angle is 50, and this angle up here is 40. Let's say that this angle in this triangle is also 50, and this one is also 40, and these are not drawn to scale. So now what I want to do is figure out what x and y would have to be in each. So this is showing you why the third angle theorem works. We've got two angles that pair up. This angle is congruent with this one, they're both 50, and this angle is congruent with this one, they're both 40. So if I wanted to solve for x here, I know that x would be 180 minus 50 plus 40. So if you work that out, that's 180 minus 90. So that angle x has to be 90 there. But if you were to work that out for this triangle too and solve for y, you would get 180 minus 50 plus 40. So you would get 90 again for this angle. So that shows you why the third angles theorem. If two in a triangle are congruent, they pair up with another triangle, then that means that the third angles have to be congruent too. So let's look at this example. What I want us to do here is to find the measure of angle O. So let's look at what we've got. We've got that x pairs up with m, and also that y pairs up with n. So that means that y is also 43. They have the same measures. So that means that x pairs up with O, and by the third angles theorem, z has to pair up with O. Okay, since x pairs up with m and y pairs up with n, then the other two angles are also congruent. So the measure of angle O is just 72. So that is a basic introduction into congruent triangles, how they work, how to list out their sides, and solve for missing lengths. And so what we're going to do tomorrow when you come in is we're going to look at a few proofs using this, which aren't too bad. Don't stress out about that. And then probably a few problems, and I'm going to let you do some work.